Today, class, in lesson 8.1, we're going to be looking at the slopes of parallel lines and perpendicular lines, and then we're going to use those slopes to be able to determine what kind of lines we are working with. This is going to be a nice little review of some of your Algebra 1 skills from last year, so hopefully you'll remember some of this as we go back to it. As we look at this diagram, this is a diagram of a new ramp at a local skate park. In this diagram, there's some things that are missing. There should be an aluminum rail that is mounted to the edge of the ramp. That's obviously not there at the moment. What we want to look at in this picture is what parts of the ramp appear to be parallel. Now, again, we are going by appearances right now, but we are going to later be able to prove them. Okay, and if we look at, since we are describing these geometrical parts of the ramp, we do need to use kind of our geometric notation to be able to do that. So, for example, I noticed that segment BD and segment EF appear to be parallel to each other. So if we said segment BD looks like it is parallel to EF, and I'm going to put a question mark because we don't know that yet for a fact. We want to look for two parts in the ramp that now appear to be perpendicular to each other. And again, we're going by appearances. We know that perpendicular means that we're looking for that 90-degree angle. If I look at the picture, it kind of looks like segment DC appears to be perpendicular to segment AD. So I could put that one down as an example. BC is perpendicular to AD, and again, question mark, because we're going to prove that in a moment. And then it asks us to look at some parts of the ramp that are neither parallel nor perpendicular. So, for example, we can kind of see if we look again at segment BC and notice how it intersects segment BD. Okay, they obviously intersect, therefore they're not parallel, but this definitely does not appear to be a 90-degree angle, so I would say they're probably also not perpendicular. So we might say BC and segment BD, okay, are neither parallel nor perpendicular. Okay, so now how could we prove this information? If we look at this same diagram, okay, but now we're going to place it on a coordinate grid. So we're looking at basically the same or a similar type of ramp on a coordinate grid. Here's where we need to review what slope means. So over in these boxes on the side, I want you to pay some special attention to the algebra connection as well as the math tip. Slope, by definition, is the ratio of rise over run. Remember that rise refers to the vertical change, so up and down, and run refers to the horizontal change, left and right. Since we're talking about, to find the rise, since we're talking about moving up and down on a coordinate grid, we know that the y values are the values that are, or is the axis that's going up and down. So to find the rise, we're going to take the two y values and we're going to subtract them. Now the run is the horizontal distance, and the x-axis goes horizontally on a coordinate grid. So to find the run, we're going to take the x values and subtract them. So the formula that you learned back in Algebra 1 was that to find the slope, and remember we use m for slope, we're going to do y2 minus y1 over x2 minus x1. And these are coming from points x1, y1, and x2, y2 that happen to fall on any particular line. So we're going to do a couple of examples. Now, some of these points were a little bit hard to read, so I did change things a little bit from the book. We are going to look at the slopes of, we're going to start with looking at the slope of segment UV. So if we look at segment UV, now, before we get started finding the slope of UV, I do want to point out that there's an error in the notes here. Point U is actually at an x value of -4 and it looks like a y value of 8. It is very important that when we are calculating slopes, since we are using these x and y values, we have to make sure that you are properly writing down those x and y values. So we are going to be finding the slope between u and v. Excuse me, I wanted to change here. We're going to be finding the slope between u and v, so we're looking at this segment, which means we're using the ordered pairs -7, +7, and -4, +8. Now again, when finding slope, we're going to start by identifying our y values, and we can choose to subtract those y values in any order. So I'm going to start with 8 minus 7. Remember that the y values will give you the rise in the equation. Then we're going to switch and identify our x values, and the key is that you have to subtract in the same order. So -4 minus -7. And then we'll simplify. 8 minus 7 is +1. When I do -4 minus -7, that becomes -4 plus 7, which gives us a +3. So our slope is 1/3. Now, the second one I wanted us to find the slope of is not VU again, since that is the same segment. This time, let's find the slope of WU. So WU, if we look back at our diagram, is going to go from here to here. And this time, we are looking at the points -10, 6 and -4, 8. So if we do the same strategy, first thing we want to do is identify our y values, and we can subtract them in any order. So I'm going to do 8 minus 6. Then we're going to identify our x values, -4, -10, and subtract in the same order. So -4 minus -10. And then we'll simplify. 8 minus 6 is 2. -4 minus -10 becomes -4 plus 10. That becomes 6. And all fractions must be reduced. So when I reduce the fraction to 6, I end up getting 1/3. You'll notice that both of these segments that fall on the same line have the same slope. So if we look at part B, it says explain how we can use this information to determine the slope of xt. Well, xt, you'll notice that that point x was not an easy intersection point to identify. It looks like the x value looks like it's around -12, but the y value is a little bit above 5. Kind of hard to tell what that y value is. But knowing that segment xt falls along the same line as those others, that tells us that all the slopes along that line are going to be equivalent. So we'll just say that all slopes of segments on the same line are equal. Okay, so now let's look at a couple of other slopes in this diagram. First one we want to look at is the slope of AB. Okay, so if we find AB, A is here, B is way over here, and our first step is going to be correctly identifying the ordered pairs. Point A has an x value of -12 and a y value of 0. Point B has an x value of 0 and a y value of 4. So we're going to find the slope for number 4A. We're going to find the slope between -12, 0 and 0, 4. And again, same procedure. Find your y values and subtract in any order. I'm going to do 4 minus 0. Then find your x values and subtract in the same order. Now be very careful here. We are doing 0 minus, and we are subtracting a -12. When I simplify, 4 minus 0 is 4. 0 minus -12 becomes 0 plus 12, which gives us a +12. And as always, we need to reduce. 4/12 reduces to 1/3. So the slope of AB is 1/3. What I would like you guys to do to get ready for class tomorrow